And today, we really have the privilege of having with us amazing women participate at WiDS at AUB. And we're going to start with our keynote speaker, Lama Nachman. She's an Intel Fellow, Director of the Intelligent Systems Lab. She has focused on creating contextualized and aware, basically, experiences to understand users through sensing and sense making to anticipate their needs. She really led multidisciplinary teams and focused on providing new user experiences, sensing systems, algorithms, applications. She really has more than 26 years of experience, and one of her most notable achievement is basically her collaboration with Professor Stephen Hawkmans, where she led a team of researchers to develop this new software platform that enabled him to communicate and interact. Really, her dedication, I think, to empower women is tremendous. Just an example, now she's joining us from the West Coast, where it is 4 a.m. her time, but she really wanted to be live. And in her keynote, she's going to be sharing with us and discussing Intel research in different applications, how this can assist people in everyday life. And, you know, when we say everyday life, this is education, manufacturing, supporting vulnerable populations, as well as producing robust and ethical perceptions to utilize all these multimodal sensing that we collect into something that will be for use. So the floor is all yours, Lama. We really appreciate your joining us live.
Thank you so much, Mariette, and I'm very, very happy to be here, and especially on International Women's Day. And I will apologize in advance if I'm not 100% coherent at 4 in the morning, but I'm going to do my best to talk about this research. So can you all see my slides okay? Okay, great. So today, I'll be talking about really this approach of human AI collaboration that we believe will kind of play a different role in changing the narratives around AI and where AI future is and where it might head into hopefully not the Hollywood perception of where life should go. To start with, just to kind of set the context. So we've all seen the amazing progress in AI technologies, and especially in deep learning, and the rapid pace of deployment of that into so many different verticals. So whether we're talking about healthcare or manufacturing or retail, and many, many others, clearly. However, we've also witnessed, specifically more recently, the growing societal concerns surrounding AI deployment, whether it's concerns around employment or privacy or safety or sustainability. So really what we're trying to do here is to kind of paint this different narrative, right? There is really a great opportunity to change that narrative from the perils of human AI competition to actually the opportunities of human AI collaboration. And if you look back at some of the research that we know in terms of diversity in the workplace, we actually know that enhancing diversity, and actually in the opening today, you know, there was that discussion about the business case of diversity. But we know that that diversity in the workplace really does bring better business outcomes. So the point here is that, you know, can we start to really exploit that diversity in humans and AI? And if you look at, you know, both of these as actual systems, you'll see many examples of AI really performing well on tasks that require things like broad exploration, analysis, and pattern recognition of extremely massive data with, a lot of different, huge amounts of data that humans really kind of struggle at doing. However, if you actually think about what humans do really well, they actually excel at learning from extremely limited data and transferring that knowledge to new domains that they have not really seen before, and being able to make these real-time inferences and decisions in very complex and ambiguous settings. And, you know, everyone that has worked in AI knows that these are exactly the areas that AI systems actually struggle with. So that's essentially kind of the 10,000 foot view. Can we actually utilize that diversity in those two actors to bring about much better outcomes? So our human and AI systems lab, right, is really a multidisciplinary team. And we bring together social science, design, and AI. And as such, we actually take a human-centered approach in our research. So we essentially go out into the world, understand everyday practices, and try to really identify where these unmet needs in these different domains so that we can build AI capabilities to help satisfy these needs. And we've done a lot of ethnographic research into the needs of people in areas like education, in manufacturing, in people with diverse needs around accessibility, and kind of looked through all of these lenses and said, where are these opportunities for human AI collaboration in these settings to help improve these outcomes? So I'm gonna, walk you through some of these examples, bring kind of that human-centered perspective and some of the ethnographic research that actually motivated a lot of that work. And I'll start with actually my favorite example, which is really the work that we've done with Professor Stephen Hawking. And really, we've been very fortunate to work with him for many years to really understand, other than the amazing human being that he is, to essentially understand these unique needs of people with ALS, which actually limits their ability to use more general assistive technologies. So if you think about that for a second, and especially think about where the advancement in human-computer interaction, we know that if someone has an inability to speak, they can actually type and use the machine, the computer with TTS to actually speak their thoughts. And we also know that people who are unable to type or have motor disability, can use, their voice to actually express what it is that they want to do and serve as that first level of interaction with the computer. However, if you start to think about this unique need for people who have extreme motor disability and an inability to speak, which is, clearly the case with ALS, but, some other diseases, then that kind of takes them out of the ability to control their PC. So in the case of Stephen, we were actually looking at, can we utilize any type of mobility that he has, irrespective of how limited that mobility is, to actually utilize that as a way to help him totally control his machine. And in the case of Stephen, actually, what we relied on is his ability to move his cheek. And what you could see actually from the picture here is that you could see this kind of what looks like a wire that's coming from his glasses. And what is actually pointing at his cheek is actually a proximity sensor. So from that sensor, what we're able to do is really extract the equivalent of a push button. So essentially the task that we were trying to do here is, how can we, with one simple thing, which is the equivalent of a push button, which then could be mapped to all sorts of different things, how can we translate that very, very limited movement to an ability to use everything on one's machine? So, and that's exactly what we tried to do. All right, there we go. I'm not sure what happened to my machine. So essentially, we went on to try to essentially build this assistive computing, assistive context-aware toolkit, which we called ACAT. And the idea of that is, can we build a software platform on top of a Windows machine that can be contextually aware, that can anticipate what the user might want to do, and rely on very, very limited movement that then we can map to the equivalent of a trigger. And then, one of the things that we've, realized is that essentially, if you think about the barriers that developers have today for assistive technology, it's really very hard to build any type of capabilities in the space, because you really kind of have to build the space from the ground up, right? And because if you just step back and say, look at something like a phone. The technologies that show up in a phone and the development cost that's needed to go build that, given the huge user base that use that, gets amortized very easily. The problem with assistive technology is that, it's very, very hard to amortize that because of the small, the economies of scale don't work, right? So as a result, what people typically struggle with is that they're going to go build something from the ground up. It's a huge, development effort. And as a result, it's very hard to actually make this accessible, even from a cost perspective, to users. And that's why you typically see, assistive technologies being extremely expensive, but also getting outdated very quickly because it's very hard to essentially keep that pace. So, so one of the things that we wanted to do is essentially build this open source platform that allows anybody to innovate in the space, and of course allow us to bring a solution to Professor Stephen Hawking and many other around the world. So one of the key elements of that was to say, how can we tailor this easily to very different needs and very different populations? And one of the things that we did early on is to say, okay, well, if we think about that population, every person will have a very different ability to maybe move a finger, move an eyebrow, be able to do some sort of a facial gesture. So we basically said, okay, let's step back and say, let's abstract this interaction to the notion of an equivalent of a push button. And let's actually then easily integrate all sorts of sensing and sense making to map this extremely limited movement to the equivalent of a push button. And once you've abstracted that from the rest of your contextually aware software platform, then you can start to easily bring in new ways to accommodate new users by really just strapping whatever that movement that they have and that sensor that you could develop into a simple wrapper that you integrate into this platform. And you could do that in the span of a few days rather than months and years, which is really what it took us to build this software platform in the first place. So, over time, we started to integrate all sorts of different sensors. So whether it's ones that are based on EOG or EMG or EEG, or even cameras, which really tends to be the almost like the universal sensor, because all you need to do is just drop a software on somebody's machine, and here you go. They have actually a software sensor to allow them to do that. Now, what's interesting here is that if you think about then what actually happens when you don't have any muscle that you can utilize. So if you have locked-in patients who have nothing really to utilize, then you really have to look at kind of a different approach. And this is where we started to focus on brain-computer interface. And what you see here is one of the platforms that we're working with, and this is actually the cap that you see Bruna, who's one of our research scientists, wearing, is actually from OpenBCI. But the idea that we have there is, can we utilize extremely low fidelity sensors, right, that are accessible to a lot of people? Because you don't want to go and buy a system that costs, $20,000 to extract really high fidelity EEG. But with this OpenBCI system, which is, in the span of a few $100s, can you actually then rely on machine learning and signal processing to improve that signal and then make it really accessible to people? And this is one of the kind of the next pieces of technology that we're hoping to actually roll out to the open source ACAT in the very near future. Now, everything that I've kind of described is, you essentially have this interface. You rely on things like word prediction and all of these different capabilities and smart sensing and understanding the context to reduce the amount of interaction that is needed. However, if you actually think about the problem a bit more from the user perspective, right, what you end up having, even with all of these advances, is essentially somebody speaking to a person with disability. And once that person finishes speaking, the person with disability will start to try to type in that way that I just described. And while this is actually faster and a lot of things are automated, you still have this kind of long pause of the silence gap, right? Because they still take quite a bit of time to formulate their letters and their words. And yes, a lot of it gets predicted, and maybe you just enter 10% of what you want to express. But still, at the end of the day, there is that long silence gap. So one of the areas that we've been really focused on is how can we actually reduce that silence gap? So now, if you think about your PC sitting in the same conversation, listening to what this other person had said, and knowing so much about the user, it can start to actually surface some interesting suggestion to the user so that that interaction can happen at that level, right? So now you're selecting one of a few responses, or you're selecting possibly one of a few keywords that were raised that then the system can generate automatically a response. And now you kind of change totally the way that that interaction happened, because it's no longer that interaction is happening at the letter and word level, but it's actually happening at the sentence level. So one of the areas we've been focused on to enable this is this human in the loop response generation system. And we all have seen fantastic advancement in response generation systems in things like Alexa and Google Home and so on. Now, the problem is, if you actually think about how these systems work, they are all autonomous, right? And what we're really trying to do isn't to replace a user with an Alexa. What we're really trying to do is enable the user to control something like an Alexa. So how do you actually bring this notion of human in the loop system that allows the user to input quickly or select from one of a few options, but have the system personalize over time to the user content and style, and then learn how to adapt really with minimal data and supervision, especially given the fact that these, we all know that the response generation systems are trained on, millions and millions of utterances. And then furthermore, can you start to actually bring in certain hints to have people express themselves in the way that you want emotions to be expressed, or things to get stressed out in different parts of these sentences. And we all know that many of these systems really require a lot of compute power to do that. And now we're trying to essentially enable the user to do that. So how do you do that in a way that you're running efficiently on platforms, that you're able to train these things with very limited data, but also not burning the planet in the process of actually continuing to train those. So those are kind of some of the challenges that we've been working on and hoping to roll that out in the near future to actually the open source community. So I'm gonna move on and talk about another area that we've been doing quite a bit of research in, which is in education. And what we know, and I'm talking to a lot of educators here, what we know from a lot of the pedagogy research is that learning outcomes really correlate very well with student engagement. So one of the areas that we're looking at is how can we utilize technology to help assess and improve student engagement. And so one of the early areas that we've done quite a bit of research in, and in fact, this research started in our lab in Turkey. So it was really trying to understand, can we enable computers to really understand student engagement and help support teachers in supporting students? And we have tons of inputs that we can rely on. We have a camera in the PC. We have a lot of information that we get from the content platform. Can the system help assess student engagement? Now, if you think about a classroom where people are actually working on content platforms, right? It's actually pretty hard for teachers to be able to understand whether students are engaged or not, because they're not engaged with the teacher, they're engaged with the content platform. So, so to try to really understand this, we spent many years in schools trying to understand what are the pain points that the different stakeholders have. Can we help support the teachers and understand really their key challenges and bring about a human AI system that can help support the teachers. And we actually, over multiple years, we've done multiple deployments, collected a lot of data, and then ended up building this system that tried to assess engagement in the classroom from these inputs, and then enable the teacher with this information to help support the teacher engage the students. And one of the things that we've seen as we kind of deployed in our impact pilots, this technology in both in a treatment class, and tried to look at the difference in interventions between classes where teachers are empowered with this and classes that are not, is that we've actually seen that the interventions change in these classes. And essentially what you start to see is that a shift from spending a lot of time trying to assess and understand and hovering around to know who's engaged versus not, as opposed to in the treatment class, seeing the teachers, kind of rely more on this dashboard and then go and try to help the student in scaffolding and helping them in sorting out what their issues and confusions are about the topic. So now what's interesting about this is that if you think about this in the context of a PC and the engagement being with the PC and the content platform, okay, well, that makes sense for some age group. But what we know from earlier in early childhood education is that that's not how kids learn, right? I mean, if you walk into a classroom for a kindergarten class, you're not going to see kids sitting behind PCs. You're going to see them on the floor, on the rug, interacting with these physical objects and learning math with their whole bodies and so on. So a lot of the early ethnographic research that we've done in this space kind of started to highlight this dilemma that parents and teachers have. So on one hand, they really want to utilize the best that technology can bring to the table. But on the other hand, they're very worried about screen time for very good reasons. So what we really were trying to think about is like, how can we actually bring that technology in a way that helps support that physical learning, that helps support the students actually learn in this physical environment? And then we kind of ended up, building this proof of concept that we're actually now testing out in classes in the US and actually later in people's homes. And the idea is this peer learner that we call Oscar, who actually inhabits the physical space with the kids. And what Oscar is trying to do, and in this specific case, we've been focused on tens and ones because at this age, that's a typical thing that they do, is actually Oscar watches over the kids as they perform these tasks. He asks them to put numbers together. He starts to actuate the physical environment to make it actually more exciting. But they can also start to personalize that physical environment, right? They can draw, and Oscar can pull in these things and then totally change the actual environment to bring whatever it is that they actually built. And then you could see them interacting physically, right, with these butterflies that they have colored, and then start to use measurements and things like that to try to actually get a lot of that math learning, but in a way that's actually engaging and physically active. And you could start to see them kind of manipulate these objects by movement, for example, or even allow Oscar to kind of inhabit that physical space with them. So you could see Oscar kind of them building a staircase for Oscar, and Oscar realizing where all these boxes are and jumping on surfaces and essentially obeying the laws of physics, even though Oscar is actually projected in that physical space. And one of the things that we've done right before the pandemic is managed to get kind of a very early on version of that notion into a classroom. And we've seen really very promising early results where we've noticed that kids are much more engaged. There is much more positive sentiments around the system, that they're actually engaged on the tasks and the physical objects rather than the screen. And that in general, they're actually showing a lot of social interaction because we wanted that to essentially be a social experience. And in this later work, we're actually bringing that into a home environment by kind of bringing in a very early version of that to make this experience extremely interactive and interesting. We've kind of talked about manufacturing. We bring actually kind of similar notion of how do we bring humans and AI together to manufacturing. But in the interest of time, I can talk about this maybe in the Q&A later if people have questions about it. But essentially, to be able to do this, you really need to enable this notion of robust perception and action in the real world. So if you start to think about this notion of intelligent systems inhabiting our spaces, doing things for us, and so on, it's very hard to do that. It's easier maybe to automate some function rather than bring this human AI collaboration. But if you actually dig deeper, you realize that there are a lot of different capabilities that really can get utilized across different deployments and across different areas, right? Whether it's response generation systems or understanding human intent and human action, or being able to create a multimodal dialogue system that can inhabit spaces and understand the context of users. Many of those things, even if you do something different in a classroom from an action perspective versus a factory, right? There are a lot of very common pieces that you can actually start to build on. And one of the areas that we've been really focused a lot on is this notion of multimodal, natural, task-oriented dialogue. So now you can, for Oscar to be able to do what it does, Oscar really needs to be able to look at the scene, observe the scene, understand what kids are doing, and then, understand their emotions, understand their actions, understand the specific tasks that they have completed, and then have that conversation with them in the context of that physical space and shared action. And then, be able to then also actuate the physical space based on that dialogue state, right? So it's not just, listening to a conversation and having a conversation, but being able to really understand more holistically all of that to make that happen. Another area that we've been really focused on is how do you enable this notion of human AI collaboration to help build these dialogue systems in a way that's much more efficient? Because, as we know from people who build actually dialogue systems, is that every single time you want to do that, then you have to kind of start from scratch, put in all of these intents, label these intents, start to build these classifiers to detect all of these intents and so on. So we've been really kind of focused on developing this notion of a human in the loop interactive labeling system, where essentially chatbot developers can interactively label and augment the training data from unlabeled utterance corpus, and then using advanced clustering and interactive labeling to be able to do this, right? So we enrich these pre-trained language model representation with some few labeled samples, and then apply data augmentation and deep clustering algorithms so that they can learn the known and unknown clusters, and then use actually human interaction for visual labeling of these clusters and intent, which essentially, from our initial analysis, we could see that we're able to achieve more than 10% gains in F1 score, but more importantly, that achieved with only 10% of that data. And then, this really kind of can be transformative to be able to actually then bring new different applications for these different interactions. So with that, I just want to finish with, in the opening, there was a lot of discussion around responsible AI. And we all know, as people who work in this space, that we have a lot of concerns. And, a lot of times we start to see these stark examples of Hollywood and AI coming in and having amazing intelligence and killing us all. But frankly, what I really worry about is more of the immediate and current concerns around AI, right? So we've seen a lot, especially when we're talking about these populations that I've described, these vulnerable populations, kids, elderly in their homes and so on. Privacy is paramount. And one of the key areas that we've been really looking at is how do we really reduce that gap between what is being sensed out of users and what is actually being inferred, right? So we've been actually even looking at alternate modalities of, do we really need to have a camera in somebody's home, or can we extract information even from things like wireless signals that can tell us what activity an elderly person might be doing in their home to make sure that they are actually okay and moving around without having to put a camera in their home. We've all heard in the opening also, the concerns around bias and how do we actually reduce bias in these systems. And that's an area that we've been focused on and trying to really leverage all sorts of uncertainty understanding to actually reduce that notion of bias and detect it as it gets deployed in the real world. And then finally, I just want to touch on transparency. When you're actually trying to build human AI systems that can collaborate and continue to actually improve these outcomes, you absolutely need to understand how these systems are built. People have to understand how to actually interact with these systems, but also these systems need to understand how to interact with humans, and being able to actually change these systems over time and understand where their gaps are. All of that level of transparency is needed to enable that vision. So with that, I'm cognizant of time, so I'm going to stop here and looking forward to an interesting discussion. Thank you so much.
Thank you so much, Lama. Amazing, very inspiring presentation and very interesting work. So I'll leave it. We have probably some time to take some questions now, and then after the second discussion or the presentation by Dr. Veronique, we'll have a longer time dedicated for questions. So there is one question in the chat that maybe I would invite Hiba to unmute and ask live. I know Lama likes the live discussions, and so Hiba, can you please unmute and proceed with your question? Okay, so let's do this. Let's whoever would like to speak, just raise your hand and unmute and directly ask the question. And whoever, for some technical reasons, cannot unmute, I will go over all the questions in the chat, and we'll make sure to address all comments and questions. Okay, so Hiba, Hiba is not able to unmute, so I will go ahead and start with her question, Lama. So Hiba is inquiring about the multimodal natural task-oriented dialogue model that you presented. She said it's pretty cool, and really it's amazing. So she's wondering to what extent the simulation and the programs or this AI human interaction systems like Oscar are like feasible basically from end-to-end thing, considering all the constraints and the lessons learned, or your deployment so far experience if you have a large number of students in the classroom.
Yeah, so that's a fantastic question, and it's definitely early times. So the way we've, just like everything that we've done in these type of deployments, is that we're essentially trying to assess multiple things, right? What is the experience that would be compelling for a child? How do we engage the child? So we're doing essentially UX research in addition to understanding the feasibility of speech recognition from kids, dialogue state tracking, intent recognition, being able to understand the scene. So essentially we're throwing the kitchen sink at all of this, and each one of these aspects of the system could fail for one reason or another, right? So early on in many of the deployments that we do is we have what we call the wizard, right? So there is actually a human in the loop that is in the background operating these systems in cases where there is an error, right? So essentially we'll see everything that the system is generating and saying, okay, this is the utterance that I understood. This is based on this experience. This is what I'm going to surface. This is the next state in the gameplay. But then a user has an ability to say, wait, this is wrong. Let me correct this, right? And so that we can actually still test out the experience, despite the fact we are still kind of improving the system and the performance of the system. And then depending on what piece of that puzzle, and I showed a huge set of different blocks that actually are needed to do that. In some cases we see actually robust intent recognition, for example. We see less robust ASR in many cases. But what's interesting is that for specific dialogue that's done in a specific purpose, you can tolerate error in the front end of that system, right? So even if your ASR, if from a word error rate perspective is a bit higher than you want, you could still tolerate that in the consumption of what the natural language understanding is doing, because the task is very constrained. I would say one of the hardest things to possibly do in that is the ability to kind of have this out of scope interaction, right? Or what we think of as chit chat interaction and things like that, which, a lot of times you will see the kids actually do, right? Because they're not scripted. They're going to go do something else that what you expect. And then one of the things that early on we've realized, and that's why, we kind of also focus on gesture recognition as one of the pieces, is that, if you look at how kids interact, a lot of time they actually point and gesture and nod their head in response to what Oscar says. So it's not sufficient to just assume that you're actually going to get the speech from the child. You also need to see the body language and the physical movements and things like that. So I would say, some areas of the system we're able to do with things like 80 and 70% accuracy. Others are more like 90% accuracy. But to put all of this together, we're still operating this. So one of our goals for the next deployment is really assess how much does a user need to intervene? So if we're able to actually, this would essentially be a measure of the progress of the different components of the system. If somebody only needs to intervene 10% of the time, then that actually tells you how accurate the system is in autonomous operation.
Yeah, amazing. I think it's a very interesting research. And as you said, this is probably one of the hardest, because when around kids, as you said, they're very spontaneous, very curious, and, whatever development and advancement in technology we have at the NLP speech, some kids probably that have some difficulties uttering their facial, this is really amazing. And the progress so far that you have achieved, I think, in having the human in the loop is definitely going to be able to help the product move into something further robust, if you want to use the engineering term, but as long as it's interactive enough and kids are receptive to it, I think it's awesome. There is another question that I'll take for the time being, and then we'll discuss in more details in the at the end of this session. So Nada is asking, Nada, can you unmute maybe? If not, I'll be very happy to rephrase your sentence, your question. Okay. So Nada is asking you that, with COVID-19 hitting the world, there's a lot of shortcomings in the health sectors that, just suddenly became so flagrant. So there's really limited capacity of hospitals, and a hospital at home system becomes more and more necessary as we go along. So she's asking you for your view. What do you think? What's your opinion on having this AI in the field of the hospital at home and its, maybe efficiency, or, your personal opinion on that?
Yeah, it's actually funny because I thought the question was going to be about COVID and schools, which actually, funny enough, a lot of the work that we've done in Kids Space started way before COVID, right? And then COVID hit, and I'm like, okay, I think we actually have something here that would actually help. But I would say it's kind of the same concept, right? So the whole point of what we're really trying to bring here isn't replacing teachers or replacing healthcare professionals or whatever, right? We think of these AI systems as ones that can increase the reach and increase the scalability of a lot of the human capability in teaching, in health, and so on, right? So if you think about that same concept, and I've done a lot of work in healthcare way back, so not recent, but one of the things that we know is that a lot of times when you're trying to diagnose things, it's very hard to diagnose them in the context of somebody's actual real life, right? So you come into the hospital, you come into the doctor's office, what you see is a very limited view, right, of that patient at that time. And specifically, if you also think of degenerative diseases, right, Alzheimer's, Parkinson, things like that, where actually the human performance changes dramatically from time to time. So one of really the areas of, that I think are extremely compelling is how do you extend the reach and the observability, right, and the ability to actually connect different factors together. Right? I know that this thing happens because this person is exerting themselves or going up the stairs or trying to walk in this context or whatever. And that's why I see that performance difference. And then figuring out how to distill, because, healthcare professionals are not going to sit and sift through 1,000 records of data, right? So at the end of the day, how do you enable the human with a lot of insights from what the AI system is able to observe and bring that in a distilled fashion? And I would argue that looks similar if you're talking about a teacher that's trying to support a child, at home, or, a doctor that's trying to support a patient when they're actually at home or out and about.
Amazing. Thank you so much, Lama. And I think we're having the upcoming session about healthcare, and I think maybe they will also comment on your perspective on that. So thank you so much again, insightful, brilliant, research, and thank you so much for sharing it. And again, thank you for being up so early to share your experiences and all this positive energy during their talk. Thank you, Lama.